This is GM Word of the Week, and I'm Fiddleback. Speleothem. It's funny how things can seemingly grow out of nothing, isn't it? For example, back in December of 2013, the angry GM started a little nothing of a blog as a side project. His idea was to create a sort of word of the day calendar for game masters. He'd take a word of interest to gamers, define it, describe it, and talk about its derivation. But then he decided that doing it every day was too much work, so he made it the GM Word of the Week. Sadly, it had very few readers, and less than a year later, in October of 2014, he let the project die. But then, in 2015, the editor-in-chief of the Mad Adventure Society, me, Fiddleback, discovered the Little Nothing blog. I was searching for new and interesting podcast material, and I convinced the angry GM that it would make a great podcast. And so I took a few of the blog entries, edited them for clarity, read them into a microphone in my sultry voice, applied some of my amazing sound editing talent, and a podcast was born. And now, here we are, 65 episodes and a year and a half in. Incidentally, that last blog entry was Doppelganger. It was our 6th episode. Why this little history lesson? Well, because that first little blog entry was the word Speleothem. And by sheer coincidence, that's our word today. And it's the word that will end our series on the natural world. It's a word that will take us into the dark underplaces of the world, places to which no adventurer is a stranger. Because Speleothem is the collective word for all the strange rock formations that adorn the caves of the world. Stalactites, stalagmites, columns, flowstone, all Speleothems. And like this podcast, those fantastic formations grow from seemingly nothing. And like this podcast, most caves in the world actually grow from the remains of previously dead things. And we aren't kidding when we say this podcast grew up from nothing. Here, now, is the entirety of that first little essay on Speleothems. It would barely qualify as a but we digress sort of side note in our current doozy of a podcast. To enter the tunnel, you force yourself between jutting, fang-like Speleothems, giving you the unnerving impression that you are entering the maw of some horrible, burrowing worm. Speleothem is the collective word for various mineral growths found in natural caves. These growths are formed when water evaporates, leaving behind minerals. There are 6 major types of Speleothems: stalagmites, stalactites, columns, flowstone, draperies, and straws. Remember, stalactites are stuck tight to the ceiling. Speleothem comes from the Latin word spelunca, which itself comes from the Greek word speleos, which means cave. Thema is a Greek word meaning deposit. That's right, 97 words. Probably barely a minute and a half of podcast time, and we didn't even describe what the heck a flowstone or a drapery is, or a straw, or go off on any weird tangents about murderous Slavic nobles, Japanese mythology, or cartoon characters. But that's the thing about Speleothems. They grow from very, very little. See, Speleothems are what are called secondary growths. They aren't formed as part of the cave itself. They form in existing caves, and they form because, as we noted, as water seeps into caves, it's carrying tiny little bits of mineral. And as the water drips onto the floor, say, it leaves behind its minerals where it lands. And those little minerals pile up and cement together until you have a pointy little pile of solid minerals. In short, you have a stalagmite. When water drips from the ceiling, sometimes it leaves little bits of mineral stuck to the ceiling, and they grow down like stalagmites in reverse. And because often stalagmites grow right below stalactites, sometimes they meet in the middle and produce a solid mineral column from floor to ceiling. Sometimes, when the water drops from the ceiling, it doesn't leave a little pile of minerals stuck to the ceiling, it leaves a little ring. And the ring grows down into a glassy, thin, hollow projection that looks like a drinking straw. And those are called straws. Straws are thin and extremely delicate and tend to grow in clumps from the ceiling. But those are just the most famous speleothems. And they certainly aren't the fanciest. Because sometimes water doesn't just drip and drop. Sometimes it flows along the ceiling along little erratic winding paths. And it leaves a trail of minerals all along the way. And other water follows that first trail, and gradually you build up these hanging, waving, curtain-like sheets of mineral. Those are called draperies. When those draperies form against walls or on the floor, we call them flowstone. But the fanciest of the fanciest, and the strangest of the strange when it comes to speleothems at least, are the helictites. Helictites are weird mineral growths that grow erratically in odd directions. There are lots of names and lots of shapes, like ribbons, saws, rods, butterflies, hands, worms' nests, curlicues, and so on. At this point, because a picture is worth 1,000 words and therefore can save us 1/3 of our 3,000 word script, we encourage you to check out pictures on the internet. They are gorgeous, and they look a bit like weird alien plants made of multicolored glassy waxy blobs. Why do we call the helictites mysterious? Well, it's because geologists still aren't quite sure how they form. Sure, they know it's all just water dropping minerals while it's just passing through, but given the shape of helictites and the strange bends and curves, it seems like the water is flowing in some pretty strange directions, like upwards or sideways through midair. But that isn't unusual for water. We've discussed before that water is a pretty nifty molecule, and one of the nifty things about it is that the molecules tend to stick to itself more than most other molecules, and that allows water to flow in some pretty weird ways. If you fill a glass right to the tippy top, for example, you can actually see it heap up over the top of the glass. And sometimes, if you leave a drinking straw in a cup of water, the water will flow up the straw. We call these odd movements capillary action, which comes from the Latin word for hair because it was first observed in long, narrow, hair-like tubes called capillary tubes. But we digress. The thing about speleothems, though, is that they are secondary growths. They don't form when the cave itself forms. They come along later as water finds its way into the cave and deposits whatever minerals it has. Which is also why they can be so beautiful and colorful. And they are often banded with different colors and appearances because, as long ages pass, different water with different minerals build on the previous minerals left behind by previous water. This has led to the term cave onyx for banded glassy mineral formations. Onyx is a type of gemstone that tends to form in layers, and so it has a characteristic banded or striped appearance. Now, cave onyx isn't true onyx, it's just bits of speleothem, but because of the banded appearance it got the nickname. But since we're talking about humble origins, you might find yourself wondering where the caves themselves came from. Why are there big open spaces deep underground? How does that happen? Well, the truth is, it happens for a lot of reasons. There's a lot of different types of caves, and the different types of caves have very distinct geologies and shapes and features. Some caves, for example, form when the rocks themselves that make up their walls are forming. These are called primary caves, and often they form because of volcanic action. As lava flows out onto the surface or downhill, the surface of the lava cools and hardens, but the lava underneath stays hot and continues to flow. If the lava drains from beneath the rock, it leaves hollow spaces which become caves. The most common form of a primary cave is the lava tube, a tube-like tunnel through which lava continued to flow after the outer surface cooled. Other primary caves include inflationary caves. These are formed when the lava traps bubbles of gas. When the lava cools and solidifies, the gas pocket becomes a hollow space in the solid rock. The simplest cave, though, often found in hilly or mountainous areas, are talus caves. These caves aren't really caves at all. They are just spaces formed when rocks break off mountains or hillsides and tumble into a heap. Often, the boulders leave spaces and openings amongst the piled up bits of rock, and these little chambers are called talus caves. But the most common, most extensive, and most impressive of caves aren't formed with the rocks themselves or just hidden spaces between fallen rocks. They come long after the terrain has formed, and they too grow from very simple beginnings. They grow because of water. Take sea caves, for example. Also called littoral caves, a sea cave occurs when waves pound against a shoreline cliff and chew away at weaker points in the rock, such as where two different rock formations meet. The waves gradually, over long centuries and millennia, chew away at the rock. As the waves tunnel into the cliff, following the weaknesses in the rock above collapses, forming caves that are partly submerged and partly above the surface of the water. Sometimes, these caves end up completely submerged and flooded. Other times, due to local geological activity or changes in the sea level, these caves end up above the ocean surface and completely dry. Likewise, rivers and streams can also find weaknesses in bare rock and chew their way through. The same process that digs huge canyons over countless eons can also carve so-called erosional caves if the stream or river finds its way completely underground. Interestingly, in some places, the scouring action of the wind can create deep clefts in cliff sides and mountain faces as well. These caves are called Aeolian caves. The name comes from Aeolus, the ancient Greek god of the winds who Odysseus visited in Homer's Odyssey. He's not to be confused with Aeolus, mythical son of Helen and Orpheus, who founded the Greek nation of Aeolia, which was later renamed to Thessaly. And neither should he be confused with Aeolus, the demigod son of Poseidon and a mortal woman named Arne, who was herself the daughter of Aeolus, the ruler of Aeolia. But we digress. So, you have primary caves, littoral caves, talus caves, erosional caves, and Aeolian caves. But those caves are all relatively simple and uncommon. If you want a truly impressive cave adventure, you need the most common and most extensive type of cave in the world. You need a solutional cave. Solutional caves often occur as part of a karst landscape, and karst landscapes also start from very simple origins. They start from ancient shells and corals. See, many marine animals, including shelled mollusks and corals, make a sort of natural cement by mixing calcium, carbon, and water. It's called calcium carbonate. Once upon a time, long ago, the sea level on Earth was a bit higher, and also the continents were shaped a bit differently. So a lot of what is land today was underwater back then. As the oceans receded, piles and piles and piles of dead mollusks and corals, as well as a bunch of dissolved calcium carbonate, were left behind. And these layers of sediments fused together into rocks like gypsum, dolomite, and limestone. By the way, rocks caused by the gradual cementing together of tiny deposits of mineral are called sedimentary rocks. These rocks have something in common. They can be dissolved by water, especially if it's slightly acidic. And most water on Earth, especially rainwater, is very slightly acidic. So if you have a big, broad landscape made of, say, limestone, and rain starts to fall and the water starts to flow, it can start to seep underground, eating its way through the rock. Essentially, it dissolves the rock. The water then gradually flows away, looking for the ocean, because that's what water does, and it leaves behind open spaces. More water can then flow through these open spaces. The initial dissolution of limestone, dolomite, and other rocks by bazillions of tiny drops of water over many years results in a solution cave. Often, these caves then become routes for streams to flow underground. Thus, the solutional cave goes through a period of erosional expansion as the streams chew away at more of the soft, soluble rock. On the surface, The result is a complex, pockmarked rocky surface with divots, depressions, little fissures, and other features with few surface rivers. In English, we call that a karst landscape, which comes from the German name for an Italian region on the border between Slovenia and Italy. So the word karst itself now refers to an extensive type of landscape, even though it was once just the name of a single plateau on a frontier border. Below the surface, though, a karst landscape is all chewed up. Winding caves, tunnels, underground streams, underground lakes, and, if they've been around long enough, they are filled with amazing speleothems. Most of the largest caves in the world are solutional caves found beneath karst landscapes. Mammoth Cave in Kentucky, which we've discussed before as the origin of one of the first adventure video games ever, is the largest and most well known. And sometimes, these caves collapse, leaving massive sinkholes on the surface. And sinkholes are so amazing in themselves that back when the word of the week was a blog, they got their own entry in which we described the massive Devil's Sinkhole in Texas. The Devil's Sinkhole is the most famous sinkhole in the world, not because it is a massive 50-foot wide, 400-deep sphincter where the ground literally swallowed itself, but because it is home to so many bats that its nightly summer bat flights have become a huge tourist attraction. How can you use all of this in your game? Well, here's where you would do well to do some research on your own, because caves are amazing, and they are so varied, and there are so many wonderful things to discover. For example, the Sun Dun Cave in Vietnam has the largest chambers of any known cave in the world. The chambers are so large that some of them have developed their own ecosystems and weather patterns. And it is also home to beautiful cave pearls, which are tiny spheres of minerals that form when the water drips too fast to form proper speleothems. The Nyaca mine caves in Mexico contain massive shafts of and deposits of quartz crystal, some of them 30 or 40 feet long and growing at odd angles through the cave walls, floors, and ceilings. Antelope Cave in Arizona is a gorgeous Aeolian cave whose walls have been scoured into smooth, undulating patterns by the wind over the centuries. There's the Fingal Cave in Scotland, which has oddly geological basalt formations that look like a pixelated mindscape landform that got all broken up. That cave is also known for the eerie moaning sounds made by the wind and ocean waves that echo through its cathedral-like chambers. And then there's the Glowworm Cave in Waitomo, New Zealand. This cave is home to scores and scores of mosquito-sized worms that hang from the ceiling. They're called glowworms because they glow with a beautiful blue-white light. The glowworms lower strands of glowing silicon into the air below them like fishing lines, and insects are attracted by the light and get stuck in a sticky substance on the strand. The glowworm then reels up the strand and its captured bug and eats it. And there are so many more amazing caves throughout the world, each filled with unique and wondrous features just perfect to rip off for your game. And so, that's the story about how complex, amazing, wonderful things like speleothems and glowworm-filled solutional caves, and a really spectacular gaming podcast about myths and science and history and culture can grow out of very simple things, like a few grains of sand dissolved in a drop of water, or the shell of an ancient mollusk, or a 100-word blog entry no one ever read. This has been the GM Word of the Week. It was written by the Angry GM and recorded and produced by me, Fiddleback. You can find more at theangrygm.com and madadventurers.com.